Today we are going to find a shape factor for this section. The dimensions are as shown here. So we have to find the shape factor. Shape factor. Now the first thing, the shape factor is nothing but the shape factor is the ratio of the plastic moment to the yield moment, MP by My. So it will be Fy into Zp by Fy into Ze. So it will be Zp by Ze. Now, so first we find the plastic. Zp is the plastic section modulus and Ze is the elastic section modulus. The plastic section modulus, so we first find the plastic section modulus. Plastic section modulus Zp. So we first find this plastic section modulus Zp. So for this, the first thing that we need to do is find out the equal area axis. So the total area of the T section, total area of the T section equals 400 into 100 plus 500 into 100 mm square. So total area of the T section is around 400 into 100 plus 500 into 100, which gives around 90,000 mm square. So for equal area axis, the equal area axis divides the section into equal areas. Let the equal area axis be at a distance y bar from the bottom. So let it be somewhere around here. So let this x6 be the equal area axis. We write here x6. Now once we do that, we can write 100 into y bar equals 90,000 by 2, or y bar equals 45,000 divided by 100, which gives around 450 mm. So y bar is 450 mm. That means the equal area axis here is 450 mm. Now we can check it like this. So 450 into 100 is 45,000. Also 400 into 100 is 40,000, and 50 into 100 is 5,000. So that gives us 45,000. So the equal area axis is 450 mm. So the equal area axis is 450 mm. So now we can easily find out the Zp. So in order to find out the Zp, we have to first find out the centroid of this portion. So let the centroid, so let us name this as A, B, C, D, E, F, G and H. So let the centroid of A, B, C, D, G, H let the centroid of A, B, C, D, G, H be at y1 bar from the top. Be at y1 bar from the top. So let this be the centroid. So the total area is 45,000 into y1 bar equals 400 into 100 into 50 plus 50 into 100 into 125 that's 50 into 100 into 125. Or y1 bar equals 58.33 millimeter. Four hundred into so y1 bar is 58.33 millimeter. Now this ZP equals 45,000. So each of this is 45,000 into the upper portion is 150 minus 58.33. Forty-five into 150 minus 58.33 plus 225. The ZP equals 45,000 into 150 minus plus 225, which is 450 by 2. This is actually comes from 450 by 2. So it becomes something like this: T minus 58.33 plus 225. So the ZP value comes out to 14.25 into 10 to the power 6 mm cube. Now we have to find the ZE. So first, for finding out the ZE, we need to find out the centroid of the T section. So this is a T section. Again we draw this, and this is around 100 mm. This is 500 mm. This is 100 and this is 400. So first we find out, let the centroid be at a distance yy from the, this is, let this be yy, the centroid of the section, and let this be y2 bar. So let the centroidal axis be at a distance of y2 bar from the bottom. So we write the equation. We write it from the bottom. So it's around 550 plus 100 into 500 into 250 equals 400 into 100 plus 500 into 100 into y2 bar. Or y2 bar comes out to be 383.33 mm. Now we need to find the moment of inertia about this centroidal axis yy bar. Now remember that this we apply the parallel axis theorem, and while applying the parallel axis theorem we have to always use the center of the moment of inertia about the centroidal axis. So moment of inertia about yy bar, not iyy equals 500. It's bd cube by 12, so 100 into 500 cube by bar by 12, 100 into 500 cube by 12 plus ah square, which is 100 into 500 into the distance, that is 383.33 minus 250. Since we are doing a square here, it does not matter whether the actual center is above or below it, so there is no negative or positive out here. So again 400 into 100 cube by 12 plus 400 into 100 into 550 minus 383.33 whole square. So we try and find out this one. So here we have missed out a so the answer comes out to be 3.075 and 10 to the power 9 mm to the power 4. The ZP becomes ZE becomes 3.075 and 10 to the power 9 by we take the bigger one because minus 383.33, so we take it's 383.33, so 3.075 in 10 to the power 9, 383.33, so this gives a value of around 8.022 into 10 to the power 6. Thus the shape factor becomes ZP by ZE, which is around 14.25 divided by 8.022, and it comes out to be around 1.78. So this is the shape factor that we have got.